Okay, this is Unit 3, Lesson 2, Reflections. Now, yesterday we did a lesson on translations. That was the first type of transformation. We did translations. Now this is the second type we're going to do. It's reflections. So his first definition is reflection. A reflection is a rigid motion in which a figure and its image have opposite orientations. I'll explain that more when we get to the examples, what that means. Thus, a reflected image in a mirror appears backwards. Okay? And again, it's a rigid motion, which means the preimage and image are the same shape and the same size. In other words, the preimage and the image are congruent. Just like translations were rigid motions, reflections are also rigid motions. A line of reflection is the line in which the points are flipped over. It is the perpendicular bisector of the segment connecting a preimage point to its image point. That's called a line of reflection. Okay, so here are 5 types of reflections that we may do in this class. We're definitely going to do the first one, the second one, and the fourth one a lot. I know that. Okay. So here are the rules. For reflections across the x-axis, the rule is xy maps onto x opposite y. That symbol means opposite. And I'll explain this more when we do the examples. But the rule is xy maps onto x opposite y. Okay. Again, opposite means whatever sign y is originally, you take the opposite sign of it. So if it's negative, it becomes positive. If it's positive, it becomes negative. For reflections across the y-axis, the rule is xy maps onto opposite x, y. For reflections across the origin, again, I'm not sure how much of this one we're going to do. I'll just give you the rule for now, and if we do any about it in the future, I'll talk about it then. But the rule is xy is going to map onto opposite x, opposite y. If you reflect across the line y equals x, and I'll get to this in a minute, because I'll show you that one, because we're going to use this one a lot. The rule is xy maps onto yx. You just switch them. And for reflections across the line y equals negative x, the rule is xy maps onto opposite y, opposite x. So you switch the x and the y around, and you take the opposite. Okay? So before we move on to like the real examples, let me show you why these rules exist. I won't show you all 5. I'll show you the first one, I'll show you the second one, and I'll show you the fourth one. Okay? So for reflections across the x-axis, I'm just going to pick a random point. I'll pick 5, 3. Let's call that A. I just picked that point randomly. Let's say let's call that A, and it's 5, 3. Okay. If I were to reflect point A across the x-axis, that brings me down here to 1, 2, right there. Okay. I'm reflecting this one across the x-axis. So this is the x-axis. If A is 3 above it, then A prime is 3 below it. So I'm going to call this A prime. And look at the coordinates of A prime. It's still 5, but now the y is negative 3.
Please pardon this interruption. Any student on the second floor that has not had their picture taken or need a retake, faculty members as well, please report to the cafeteria at this time.
Okay, so A got reflected across the x-axis to A prime. And look what changed. The x did not change. The x is still 5, but the y value changed. It changed from 3 to -3. So that's why the rule is xy maps onto x opposite y. So you may think the x changes, but no, the y changes. Now let's look at the next one. Let's start with the same point. Let's start with 5, 3 again. I'll call it B this time. Let's call it B. Say B is 5, 3. So if I reflect B across the y-axis, this is the y-axis this time, that brings me way over here. Okay, so again, if B is 5 to the right of this line, so B prime is 5 to the left. So this is B prime when I reflect it across the y-axis. So what changed? The x value changed. This is -5, 3. So you'll see the rule above, xy maps onto opposite xy. So opposite x, 5 goes to -5, comma 3. So when you reflect across the y-axis, the x value changes. And let's do one more. Let's do reflections across the line y equals x. So the line y equals x, let me draw that in right now in case you're not sure what that is. This is the line y equals x. Everywhere on that line, y equals x. Check this out, okay? 0, 0, that's 1, 1, that's 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, -1, -1, -2, -2, -3, -3, and so on. So this is the line y equals x. Everywhere on that line, x and y are the same. So let's start with the same starting point. Let's start with, I've been saying 5, 3 each time, so let's do the same. 1, 2, 3, 4, 5, 1, 2. Let's say this is C. I did A, B, now let's call that C. If I reflect this point over that line, it brings me right here. So that is C prime, and that is 3, 5. If you can imagine, if you were to fold your paper along this line, then C would end up right there at C prime. So you'll see that the x and the y have flipped. 5, 3 mapped onto 3, 5. So that's why that rule is xy maps onto yx. I did the fourth one. Okay. Now let's move on to the examples. Okay. Give me 1 second to straighten this out. Okay. If point P, which is at 2, -1, is reflected across the line y equals 1, what are the coordinates of its reflection image? Now, one thing you need to know is that whenever well, let's plot point P. Let's plot point P first to get that over with. Point P is at 2, -1. Okay, so I'll just label out. Let's point P. That's going to be reflected across the line y equals 1. Now, you need to think back to algebra. What does the line y equals 1 look like? It looks like a horizontal line at 1. Whenever you have y equals a number, it's a horizontal line at that number, okay? Because everywhere on this line, y equals 1. That's 0, 1, 1, 1, 2, 1, 3, 1, 4, 1. Y equals 1 everywhere on that line. So, if P is 2 below that line, then P prime is going to be 2 above that line, which is right there. So that is P prime. The coordinates are 2, 3. Because the line of reflection is the perpendicular bisector to the image and the preimage. It's halfway in between them. So I'm going to say the coordinates of P prime are 2, 3. if point Q, let's graph it, negative 2, 5. It is reflected across the line x equals 2. So again, think back to algebra 1. Whenever you have x equals a number, that's a vertical line at that number. So this is going to be a vertical line at 2. I'll label this is Q, negative 2, 5. Okay, so now reflect point Q across the line x equals 2. Okay, again, this is the line x equals 2 because everywhere on that line x equals 2. That's 2, 0, that's 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and so on. So anyway, look at Q. Q is 1, 2, 3, 4 units to the left of my line of reflection. So that means that Q prime is going to be 1, 2, 3, 4 units to the right of my line of reflection. So this is Q prime right there. Q prime is at 1, 2, 3, 4, 5, 6, 5. Okay, so I'll say the coordinates of Q prime are 6, 5. Okay, example 3. Graph the image of triangle ABC after a reflection across the x-axis and complete the table. I'm going to complete the table first. Okay, so in my top row in the table, I'm going to put my reflection rule, reflect across the x-axis. So the rule is xy maps onto, when you reflect across the x-axis, think back to the first page. The rule is xy maps onto x opposite y. Okay, so if you forgot that, that rule is on the first page in that table we did. Okay, and let's go in alphabetical order in the table. So ABC is going to map onto A prime, B prime, C prime. So A is at 2, negative 1. B is at 1, 2, 3, 4, negative 5. And then C is at 1, negative 5. So the rule is xy maps onto x stays the same and take the opposite of the new y. So A prime will be at 2, 1. B, 4, negative 5 maps onto B prime, 4, 5. And C, 1, negative 5 maps onto C prime, 1, 5. So you're taking the opposite of the new y coordinates. And now let's graph it. So 2, 1, 4, 5. And then 1, 5. Connect the vertices and label. And again, these are all rigid motions, so the pre-image and image should all be the same shape and the same size. Okay, so this is C prime up there, this one was B prime, and this one is A prime. Now this one you don't have to, you can graph it without making the table, but I asked you to make the table, so you had to fill in the table. You could just think about it. A is 1 below the x-axis, so A prime is 1 above. C is 4 below, C is 5 below, so C prime is 5 above. B is 5 below, so B prime is 5 above. Example 4, we have the same pre-image, and now I want you reflected across the y-axis. So let's make the table first. XY maps onto, when you reflect across the y-axis, it means you change the sign of the x. So XY maps onto opposite x comma y. That is the rule. Okay. So let's make the table in alphabetical order, A, B, C. Always go in alphabetical order, just so it's easier for me if you hand in the paper. Okay, so A, B, and C is the same as the first, as example 3, the same preimage. So A is at 2, 1. 2, negative 1. B is at 4, negative 5. And C is at 1, negative 5. So now take the opposite of the new X. So A, 2, negative 1, maps onto A prime, negative 2, negative 1, because you're taking the opposite sign of the new X. So B, 4, negative 5, maps onto B prime, negative 4, negative 5, and then C, 1, negative 5, maps onto C prime, negative 1, negative 5, and then graph each of those. Again, these are all rigid motions. The image and preimage should be the same shape and the same size. Okay. And label A prime. This is C prime. This is B prime. Again, look, A is 2 to the right of the y-axis, so A prime is 2 to the left of the y-axis. C is 1 to the right of the y-axis, so C prime is 1 to the left. And B is 4 to the right of the y-axis, so B prime is 4 to the left. Let's do one more. Again, the same preimage, graph the image of the triangle ABC after a reflection across the line y equals x. So just to show you again, this is the line y equals x. I'll graph that right now just so you can see it. That's the line y equals x. We're going to reflect it over that line. Okay. So again, let's make the table first. xy maps onto the rule from the first page. When you reflect across the line y equals x, is xy maps onto yx. So again, table, alphabetical order, ABC maps onto A prime, B prime, C prime. A is at 2, negative 1. B is at 4, negative 5. And C is at 1, negative 5. Okay. A prime, switch x and y. xy maps onto yx, so A prime is negative 1, 2. B maps onto B prime, negative 5, 4. C maps onto C prime, negative 5, 1. Graph that, and then we'll call it a day. Negative 1, 2. Negative 5, 4. And negative 5, 1. Connect that and label. Label the vertices. There we go. This first one is A prime. Don't forget the prime symbols. This one up here is B prime. And this one over here is C prime. So if you were to reflect, if you were to fold your paper along this line right here, A would go to A prime, C would map to C prime, B would map to B prime. Okay. But again, the key is you need to know these 5 rules. These are the 5 rules of reflections. We focused mainly on the first, second, and fourth ones in this lesson. Those are the 3 we're going to use the most, but you may come into contact with the other 2 throughout this class as well. And that is the end of that lesson. That was the second type of transformation we did. This transformation, again, was called reflections.